Hi everyone, how are you? I hope you are doing well. Today, I'm going to give you a demo about our SHACPE application. It's a scientific hypothesis autonomous causal pathway engine. It autonomously generates scientific hypothesis, specifically in biomedical research. I'm so excited to start this demo with you. I'm going to log in with my account. First thing you need to know, you should have enough balance in your account. For renewing your balance, you can click on usage and history and go and purchase from here from the packages from our packages suitable to your use case. And after that, you need to create new project. Let's start our project demo and create. Now you can start writing manually your research question in form of search a PubMed search query, or you can use our AI assistant to help you to do that. And in here, I'm asking my research assistant to make a research protocol about this research question. So, what are the molecular and cellular mechanisms through which COVID-19 leads to chronic fatigue syndrome? I would like to understand the underlying pathological and physiological mechanism for that, and click generate protocol. My AI assistant now is yeah now I have my protocol. So this is the search strategy. You can make sure that everything goes on the right direction you want. So this is my search strategy, and this is protocol. The question, what is the molecular cellular? This is my research question, and this inclusion and exclusion criteria. Click apply protocol. In here you can manually also change everything you want to change, anything you want to change to match your use case. You can add more inclusion criteria in here, or exclusion criteria, and start search. It will search PubMed for you, and now uh, it identified 20 results. You can increase this to include more studies in your outcome. Add all of the results to your library. You can manually uh, go to every one of these research abstracts and click include or exclude. But in here, I'm going to use deep screen with AI. So my AI now is going to automatically screen all the literature that I have, and uh, it will decide uh, according to my research protocol which studies to be included, or and which study to be excluded. It will take time. Okay, now we started to see action. So this study, for example, is excluded, and this is the reasoning why it's excluded. And this study is included, and this this is the reasoning behind why it is included. We have finished 25% until now. It will take more time. We finished about half of the studies. Let's wait a little bit more. Just more few seconds. Okay, we have finished everything now. There's some studies, our AI is not certain about them, so it didn't include or exclude. It signs them as uncertain. I'm uncertain about these studies. You can check like exclude, include, etc. For example, let's include this, uh, and okay. Now we can go to the Prisma chart flow. Identification, we identified with studies. Screen 16 studies, excluded 7, included 9. Okay. Now let's go to the next step, which is extraction and pre-processing. Now run our extractor. It will extract the information from these studies automatically according to our research question. And after finishing this step, it takes time. After finishing this step, we will start processing. Okay, now we can see action. For example, these are the extracted pathways. Endothelial damage cause altered endogenous peptide excretion. Homeostatic imbalance cause altered, etc. And yeah, for example, here long COVID associated with fatigue, post-exertion malaise. Okay, allergic colitis, chronic fatigue syndrome is associated with fatigue and post. Okay, it's like the opposite. And it will continue. It will continue extracting all the information from the studies, the included studies. Post-acute sequel of SARS-CoV 2 infection is associated with urinary peptidome profile. Okay, we have finished 5 studies. Let's wait a little bit more. Until now, we have 50 pathways extracted, 62 subject, and objects, 41 objects. In real world example, in a real world case, you will definitely include more than 20 articles in your search results, PubMed search results, and you will do more processing. You will take uh, 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 a little bit more time, not a little bit, but more time, definitely more time for processing to make a comprehensive overview of your research question. You should include at least 1,000 study in your search outcome. Okay. uh, Start processing. Processing also takes time because now we are going to generate embeddings, and after that it will start clustering these embeddings, and it will do more normalization to the entities that we have extracted from here, so that it can be more analyzable in next steps. Let's keep waiting. Can navigate the extracted pathways in here to make sure that everything goes in the right direction. While doing that, you can grab your coffee and enjoy your coffee while your AI is doing the work for you. Okay, now we have finished two steps, and now we are making normalization to the extracted entities or extracted pathways. Normalizing entities takes a little more time than other, a little bit more time than other steps. Yeah, okay, now we have finished everything. Let's click save. And now we are ready for the next, we are ready for the next steps. Uh, okay, let's now plot our graph. So finally, we will have this graph. Okay. If we zoom out, we can see that there's some clusters, definitely, colored in different colors. You can visualize your clusters from here in the network anatomy. Go click on the network anatomy. Okay, you can click in here and open network anatomy. And we have three clusters in here. The first cluster is post-COVID sequelae mechanism. Second, it's myelogenic colitis, chronic fatigue syndrome, pathophysiology, and BASC biomarker and information. Okay, so these are three different distinct clusters. You can see that myelogenic colitis node is taking the highest highest degree and takes top connector. We have in here network connectivity on topology matrices as for the nodes and for the entire network. Now you can click and grab. Okay, COVID-19 related brain damage. It is associated with immune dysregulation. It is associated with impaired glutamate homeostasis. Is associated with glial and glymphatic drainage disturbance. Associated with hippocampal degeneration. Okay, this is interesting. And because our literature included in this demo is not big enough, we don't have we don't have a very big network or interconnected network, but however we still have some connection between this hub and the other network. Okay, still in here, chronic fatigue. Okay, and still we're still in here in the red post-COVID sequela. Uh, yeah, interesting. And managing colitis. Yeah, okay. You can click in here and edit your any node of the nodes in here, or you can add a connection, new connection between having here, or remove any of these connections or adjust on them. If you click on here on one entity or one node, for example, mild severe acute respiratory syndrome coronavirus 2 infection, you can see the node level connectivity matrices, the degree, the centrality, clustering, coefficient, influence, and you can see the reference associated with this node, and it comes from it, and you can open it and read the paper and make sure that everything is good and accurate. If anything you suspect not accurate, you can uh, go back and edit it from here. And finally, we will go to analytics. And here we have three clusters in our system map. You can click in any of any of these or the three of them. Let's click only on one of them right now and generate summary for what is going on underlying this cluster. And yeah, you can read the summary from here. The BAC or pathophysiology pathway represent a key signaling cascade involving 20 molecular component. This pathway modulates post-acute sequel of SARS-CoV-2 infection, pathophysiology through coordinated interaction, etc., etc. You can directly use this to generate a scientific illustration, or you can refine this in a more bland and more organized manner. Also, worthy to mention that everything in here is written and associated with its reference, so you can use this reference in your text later, and you can make sure also that everything or every information mentioned here is accurate and not hallucination by AI. And okay, now let's refine and make our plan, our illustration plan. It will take few seconds to change this text into a scientific illustration plan. Okay, now biorender visualization plan, etc., and the overall aesthetics, nature style review, clean, minimal. Let's remove this clean, minimal, text label. Okay, etc., etc., and click create illustration. It will take few seconds to create our illustration. We are generating our 4K image. Okay, now the pathophysiology, SARS-CoV infection, and this is the first pathway. I think the quality for this pathway is not good enough, so I can go and change the model because now we are using for this illustration purpose. We are using Gemini Flash image generation. It is Nano Banana Flash model. It's not the most accurate for scientific illustration. You can change this in your system and use the Pro model. It will generate uh, accurate, 100% uh, accurate illustrations for you. We can click in here and make it generate again. Okay, this is a little bit more better, and you can download your illustration and in your Canva uh, or any editor, photo editor, you can use this things and correct the text in here and do more edit on in your graph. Thank you so much. Thank you so much for staying with me for this illustration, and we conclude our demo at here, and looking forward to hearing back from you. Thank you so much. Goodbye.